Hi Nationals. So if we were in the class, we would be doing nuclear chemistry in maybe a week. We've been moving along a little bit slower in lockdown, so we're going to spend 2, possibly 3, okay, maybe 2 weeks on nuclear chemistry. So nuclear chemistry is all to do with the nucleus and an atom. So a bit of revision. So remember, atoms made up from 3 particles. Okay, we've got protons, neutrons, and electrons. Now we should know this from our unit 1. Okay, really important that you know the charges, the mass, and your locations for all 3 particles. So inside your nucleus, what you've got is you've got your protons and your neutrons, and the electrons orbit the nucleus. So your atomic number is always going to be equal to your number of protons. Now in your nuclear notation down here, your atomic number is always the one down the bottom left. So if an atom, okay, remember not an ion is when you can gain or lose electrons, but for an atom, the protons is equal to the number of electrons also. Mass number is going to be equal to your protons plus your neutrons added together. So remember, the electrons don't have a mass, they're so small. We say that the mass is 0. So the mass number is made up of the protons and the neutrons added together. And in your nuclear notation here, that's your mass number at your top left. Again, from Unit 1, you need to know what the definition of an isotope is. An isotope is the same atomic number but different mass numbers. They've got the same number of protons, but they've got a different number of neutrons. So we've got 5 questions here that we want you to write the answers to, and these answers are to be sent to your teacher, okay, as part of your work. Obviously, it's supposed to be taking your own notes as you go through this. Be revision notes also issued. Well, this is some of the questions that your teacher's going to be marking. If you're watching the video rather than going through the PowerPoint, so pause the video now so you can do these questions. Also, I want you to write the nuclear notation for these questions here. Now, remember nuclear notation, so you're going to have your symbol. So I'll talk through the first one. So your symbol is going to be F, fluorine. It's got 9 protons. So remember, the number of protons tells us what the atomic number is. And it's got 10 neutrons. So we can work out what the mass number is. So remember nuclear notation, atomic number, bottom left hand side, mass number, top right hand side. The atomic number is given by a number of protons. Your mass number is your protons and your neutrons added together. Now we've got 3 different types of radiation that we need to be aware of, and we need to be able to describe the properties of each of these. So alpha, beta particles, and we've got gamma rays as well. The radioactivity occurs when the nuclei is unstable, and what happens is energy is released, and it's often a particle is emitted. Watch the YouTube video at the bottom of this slide. So the first type of radiation that we're going to look at is the alpha particle. Okay, so it's been denoted by this little alpha sign up here. So it's a little A but with a tail. Now the alpha particle, what it actually consists of is 2 protons and 2 neutrons. If you think about helium, helium's atomic number 2 and it's got a mass number of 4. So helium is actually 2 protons and 2 neutrons. So an alpha particle is a helium nucleus. So it's got no electrons, it's just the helium nucleus itself. So you can see the symbols written down the bottom here. So the symbols for the alpha particle could be either written as this here with the alpha sign, or an He for helium with atomic number 2, mass number 4. So it could be written either way here. So this type of radiation is called the beta particle. So it's given by this symbol here. Now, a beta particle is a high-speed electron that's been emitted from the nucleus. And the symbol for the beta particles, we can say the little beta sign of a -1, and 0, or the E for electron. Now the question is, how can an electron be emitted from a nucleus when the nucleus doesn't contain any electrons? What happens is a neutron is broken down to make a proton and your electron. The third one that we're going to look at is gamma radiation. Now gamma radiation is not a particle, so it's on the electromagnetic radiation spectrum along with your X-rays, radio waves, but it's a higher energy wave. So therefore it's got no symbols, it's got no mass, and it's got no charge. So when the gamma radiation is emitted from the nucleus, there's no change from the nucleus. It's not losing any protons, it's not losing any neutrons. Now this is a common diagram that you may be questioned on. So you've got the radioactive source that's been emitted, and this has got your alpha, beta and gamma rays all been emitted. You can see here the gamma rays just pass straight through the electromagnetic blocks. The alpha rays, they've been attracted to the negative side. Now remember what the alpha rays are. Okay, they've got 2 protons and 2 neutrons, so they are positive particles. Okay, your beta rays, that's your high moving electron, your high speed electrons, so they've actually been attracted up here to your positive, travelling up here. Now, these have been deflected faster than what your alpha particles have been deflected faster, and that's because they're lighter particles. So that your alphas, your helium nucleus, they're a bit heavier, so they take longer to deflect. The penetrating powers. Now what this means is what type of materials can stop your radioactive source. Okay. So again, you've got your radioactive source coming out your block here. Okay. Your alpha, your beta and your gamma. The first material you've got to pass through is a sheet of paper, and this stops your alpha. So we say that alpha particle can be stopped by a sheet of paper. A few centimetres of air can also stop it as well. Your beta particle, that keeps going, but then it gets stopped by aluminium by about 6 millimetres. However, your gamma ray, that keeps going. It needs either thick lead or concrete to be able to stop it. Have I got these 4 questions? The answers are on the next slides. Okay, but try not to look at them. Just do the questions and then self-mark them. Again, if you're watching the video, you're going to have to pause it at the moment to do these 4 questions. Just always remember that writing the nuclear equations is quite similar to writing any other balanced equation, where the mass number and the atomic numbers must be balanced on both sides of the arrow. Okay, given this example here, you see the radium on the left hand side has got an atomic number 88. On the right hand side of that arrow, the alpha particle atomic number 2 plus 86 and the radon equals 88, so it's balanced. Same as the mass numbers. 218 plus your 4 is equal to 222, same as your radium. So when a beta particle is emitted from the nucleus, always remember it's because the neutron is breaking down and it produces a proton plus your electron. So whenever a beta particle is emitted, you're always making that proton as well. So overall, you're going to be increasing your atomic number by 1. So these are examples of the beta emitted. So I'm just going to talk through even just the first one. So the lead's atomic number 82. Now, because it's emitted a beta particle, which means that it's also created a proton, so the atomic number goes up by 1. Okay, mass number is going to stay the same because the electrons doesn't have a mass. So just think 83 plus your minus 1 is going to be equal to 82. It's the same on the left hand side.